Indeed. It so happens you are here just in time, Mr. President, Major Agnew. Behold then, the giant
stem cell.
Mr. President.
I have a question. Might this
Stem cell.
not also have some military application?
A military application?
Yeah.
Oh, yes, of course. A military application. Yes, I'll just go and check.
Stem cell therapy has the potential to revolutionize combat medicine and aid in recovery of wounded soldiers, both on and off the battlefield. This video explores the primary mechanisms of how stem cells can be utilized for application in the military, and sets out to understand how stem cells may help in treating various tissue damages resulting from modern warfare. As always, the sources are in the description. In wartime, combat injuries introduce a new set of trauma patients into the military medical system. These injuries often come in the form of blast injuries, although in contemporary conflicts, explosive attacks often lead to a wide range of severe injuries involving several organs and tissues. Stem cells serve as the building blocks for regenerative medicine, and have been identified for regenerative treatments in eye tissue, cochlear hair cells, which are essential in the ear canal, heart and vascular tissue, skin grafts, and the musculoskeletal system. Despite the modern advancements and implementation of better body armour, trained combat medics, point of injury care and rapid evacuations, musculoskeletal damage is present in almost all of modern combat injuries. As a result, this has become a prioritised area of military research. Musculoskeletal injuries greatly limit patient mobility and are often accompanied by high levels of pain. Mesenchymal stem cells hold the key to creating the principal cell types of the musculoskeletal system. The United States Armed Forces Institute for Regenerative Medicine, or AFIRM, is a multi-institutional interdisciplinary network which works to develop advanced treatment options for severely wounded servicemen and women, and has proposed the restoration of function to limbs that would otherwise be amputated. AFIRM have launched a long-term initiative to regenerate and regrow injured soldiers' limbs, arms, and other extremities. Their work extends to clinical trials in all injury areas, including facial and skull reconstruction and even face transplantation. I may have to do a video just on AFIRM at one point to cover all of their amazing work and research. In 2008, AFIRM began utilising stem cell technology to regenerate new body parts, including skin. The US Army Institute of Surgical Research developed the Engineered Skin Substitute, a bioengineered skin substitute that uses tissues made of the patient's own collagen-producing cells to replace the top two layers of damaged skin. Commercial examples of this include Myaderm, an autologous bilayered engineered human skin tissue technology which allows for treatment of major skin loss. AFIRM has envisioned a project of storing skin samples for every soldier in dangerous areas, so that the moment a soldier is injured, people could start growing required cells for graft. Current use of high explosive fragmentary munitions has resulted in a higher rate of severe ocular injuries, and auditory loss is one of the more common sensory losses from blast trauma. Stem cell treatment has been considered for these injuries. While eye transplants are a rare possibility, recent advancements in stem cell research has led to the production of retinal and limbal cells from embryonic sources. Auditory injuries are more difficult to treat with stem cell advancements. Even minor damage to non-regenerative cochlear hair cells can result in permanent hearing loss and vertigo issues. While stem cell transplantation from various sources has shown some success in animal models, it's not been entirely effective. Alternative to purely injury-led applications, stem cells are being investigated in other areas to utilise all of their unique properties. For years, the military has been searching for synthetic or easily obtainable sources of red blood cells and platelets. During mass casualty events, blood shortages are common. To address this issue, the Defense Advanced Research Projects Agency is funding projects to develop new technologies for producing readily available red blood cells in vitro. Stem cells have long been recognised as a potential solution to the problem of blood supplies. You can see my recent video on one of the current UK projects on growing red blood cells from a stem cell source. A proposed method to allow a source of stem cells required for limb regeneration is to establish a system of induced pluripotent stem cell biobanking. This system would involve storing cell samples from active military personnel before deployment, which could then be reprogrammed into autologous immune-compatible induced pluripotent stem cells and preserved for long-term storage. When required, the cells can be differentiated into the desired cell types and used for a regenerative therapy. With ongoing developments that may enhance the system's effectiveness, stem cell biobanking is a promising concept for consideration. Although the potential of stem cell technologies is still yet to be realised clinically, possibilities for regenerative medicine advancements makes them a topic for significant interest to the military. As research continues, the future advancements in stem cell technologies will lead to the benefit of those who serve in the armed forces. Thank you for listening to this video today. I'm hoping to do another video on gene therapies and their potential use in the military. Thanks for watching, and I'll see you in the next video.